So hey there fellow YouTubers, Frank Bush here again. So in today's video I want to kind of discuss, if you've got multiple small scale solar energy systems and you've got very different types. Like in this example here, I've got a battery with an inverter and a charge controller, which is very conventional kind of setup. Or if you're going kind of with an all-in-one unit that's a portable solar generator, we've got a couple different kinds here. And some of the problems that you run into by not having high levels of compatibility with each other because of different wirings and those types of things, and potentially having some limitations to the performance you're going to get out of these devices. And I'm going to go through connecting some of these things together to show you how you can increase some of the performance and kind of get some good hacks, even if you're using small generator systems. Yeah, so if you're interested in that kind of content, stay tuned. So I guess the first thing I want to kind of discuss in this video is what led me to making this video. Other than the fact there's monsoon rains outside, I think they call it an atmospheric river that's going on in my area. So I'm not really keen on doing an outdoor video right now. I'm just going to do an indoor one. But one of the things in one of my recent previous videos, I reviewed this R600 and its performance. And one of the things I found was this had a strict 10 amp restriction on the 12 volt cigarette lighter adapter socket that is here. So when it came to using stuff that I've shown in many other previous videos of cooking utensils like this pot or this immersion heater that I have here, this simply wasn't putting out enough amps and it was shutting down before I could use it. And the first initial thought would be, well, this generator just doesn't have the ability to run something like that. Yeah, and it's more to do with the circuitry than it is the battery capacity or anything else. So I'll just turn around and plug this in and show you an example of what I'm talking of. As soon as I plug it in, you'll see this light comes on here. Hopefully the camera's picking this up, but the watts jump up and they go above 120 watts. And this R600 has a really strict threshold on that. It just won't allow any more power to be drawn before it shuts itself down for safety reasons, which makes perfect sense. But these devices here, they typically use a couple amps more. They use like 12 amps or so instead of 10. So it wants to trip this. Now, in order to get around this, I'm going to show in the video kind of a compact circuitry that I have that I can use in combination with this to allow me to still use my normal 12 volt cooking utensils. And then I'll talk about the flexibility of using that between different systems and that kind of stuff. So let me just kind of pull in the other gear, shift camera angles a little bit, and we'll go on to the next scene, yeah? All right, so now I'm going to show you this thing as part of my solution for getting these cooking pots being able to run off of this small generator that I have here, yeah? So, and one of the critical components will be this DC switch mode power supply. It goes by a few different varied names, but in essence what it's doing is it's turning conventional wall power, like you plug into the wall, yeah, and it turns it into 24 volts. And I chose 24 because I wanted to have a really flexible system, because I've got further circuits that are a little further down the line here that I'll talk about in detail and I've mentioned in previous videos, that allows me to go from 120 volts off the wall to either 24 or a 12 volt based system, and I can plug things in quite easily, and it gives me a lot of flexibility with the way I've constructed this. So I'll shift camera angles and I'll come in a little closer on this unit specifically, and the thinking and kind of walk through its details. And the thinking really is, like I say, this unit can plug into any AC output. So I'll take the classic kind of solar generator system I have with a battery and inverter I've got sitting over here. I'll just turn that on and plug this in. And you can hear when the fan kicks in, it makes a bit of noise. So I won't, it's not critical that I'll just turn that off for right now. It's not critical that I have that running right this second. But I'll have to turn that fan on in a bit, and potentially it'll interfere with me and the mic and stuff, right? But what I'll do is I'll come in close, like I say, and show you exactly what I've done on this end and the thinking behind why I've done that and kind of the flexibility it gives me, yeah? So give me 2 seconds and we'll continue. So I'll just kind of show you where all the connections happen on this little unit. So this is where the plug that goes off to the wall plugs in. I've got my live my neutral, and my ground going here of the black, the white, and the green. And if you don't know about this stuff, really make sure you fully know what you're doing before you go and make these kind of cuts and extension cords and, you know, connections and that kind of stuff, yeah? You know, if you have any questions of what you're doing, don't do this part. It could be a risk to you. You know, if you know an electrical person, they might be able to help walk you through this, but that's what it is. I've got the black into the live, the white into the neutral, and the green into the ground. And now on this side, I've got 3 negatives out that are all producing 12 volt and 3 positives. And these are the terminals I can screw wires down to that sit in here. So you get the 3 negatives, here, I'll pop that open. You got the kind of 3 negative slots on that side and the 3 positive slots on that side. And what I've done is, and there's a little tuner here where you can fine tune what the voltage is. So you can make it, you know, right now I've got it set to exactly 24 volt, but I could adjust that a little higher or a little lower if I wanted to have this for charging batteries and other things, but that's all future video talk. But generally speaking, I've got these connected where I've got typical, if you watch previous videos of mine, you'll know that I use MC4 connectors. Now these are standard that you'd see on solar panels and stuff. So what I've done is I've wired up the output in the DC that's coming off this as 24 volt, just like a solar panel would have. And allows me to now make any connections that I have with these MC4 connections to other units, which I'll talk about in a second. And in essence emulates as though it was a solar panel. So I could easily plug these connections in to any one of the solar generators that I have that have typical MC4 connections, you know, that they can handle and deal with. That's pretty standard across the solar generator platforms. It's compatible to all of it. So, and when it comes to the wire sizes and stuff, I use a 10 gauge, and these MC4 terminals, they're rated at 30 amps. So with a unit like this, it's a 700 watt unit, and these lines can handle the maximum that this would put out. This puts out about 29 amps as its max, and these can handle 30 amps. And because I've got a short run, it makes it a little even better. The longer the runs are, the thicker the wire you have to use and stuff because of losses and other things. But I'll now talk about, so like I say, I can fake like these are solar panels, and I can plug this into the wall. So if I'm at home and I don't want to, you know, or I don't want to bring my solar generator out in the yard, but I still want to charge it and I don't have another charger for it, it's purely solar panel driven, I can use this setup to plug in my connections that go off to my solar generator directly to these, and I'll show an example of that as we go. But you can also plug them off to other things, and that'll shift me to the next scene, yeah? So 2 seconds, I'll shift cameras and we'll focus in on the next part. So, and you can see here where I've got one of the outputs coming off of my DC switch mode, my 24 volt, if you will. One of the MC4 connections I've already hooked up now to this unit. Now this is called a buck converter, and I've showed this exact unit in previous videos that I've done. And I already had this wired up with the MC4 connections as well, because I can connect a solar panel directly to this unit and produce power. And I've done full detailed videos on that where there's no battery involved and that kind of stuff, yeah, at all. But in this video, we're going to talk about batteries and that stuff more, right? But what this unit does now is it takes the 24 coming off the first unit, that switch mode power supply that we have up here, and it converts it out to 12 volt now, which is the same as like you'd have for cars and that kind of stuff, yeah? So 12 volts pretty standard. There's lots of appliances and that run on it. And I'm back out to the point where I've got the cigarette lighter adapter, yeah? So now I know that when it comes to this unit, it can handle 240 watts worth of DC. I was flipping this small generator when it went above about 10 amps, which is 120 watts through its cigarette lighter adapter. But with this other unit that I have here, I've got a 15 amp fuse in line, and I've used thicker wires so I can handle a higher level of amps. So this unit can actually, I believe I've got this at a 20 amp limit. So I can push that fairly significantly up to the 240 that's here, but typically speaking, all the loads I conventionally have are a couple amps below that to be within a safe threshold and that kind of thing. But all I need to do now is plug in this DC power source here. I just got to plug that in to say the AC output on this R600. And then it should have electricity flowing from here through the DC power, making it 24 volt, out through the buck converter, making it 12 volt, and then out to my cigarette lighter adapter. And now it'll be a direct head-to-head, if you will, of my cigarette lighter adapter setup now to this, yeah? So I'll shift camera angles and we'll show you that as the next scene. Okay, so now we're at the point I'm going to have to turn the fan on because I got to start supplying power to all this, right? So I'm just going to turn on my inverter here, which I've already got all hooked up, yeah? And now this kicks on. The fan's going on that, but the power is now flowing from this inverter at 120 volts AC, out to this, turning it into 24 volts DC, out to the buck converter, turning it into 12 volts, and then coming to my cigarette lighter adapter. And now this is to plug in this pot I have sitting here, which I wasn't able to start before at the beginning of the video, plugging directly into that small generator unit. Now I can. The other fan kicks in, so it makes a bit more noise, but you can see I'm successfully able to keep this pot running. Now it's just sitting empty. It's just going to get warm in a hurry. Ah, yeah, I can already feel it starting to heat up. Yeah. So needless to say, I won't leave it running for too long, but I'll let it run long enough to show that it's not going to trip, yeah? So just having this unit in here allows it where a small generator like I'm using can actually be pushed well past the threshold of the limitations that it has on the circuitry here at the 10 amps. I'm coming out at 12, probably 13 amps, to be honest, at this location. And if we switch this around and wire it up a bit, I'll show you exactly how much this is pulling, because we'll start to use the R600 instead of this inverter now to supply the power for it, yeah? So I'm simply just going to unplug the inverter from, or the extension from the inverter, and now instead I'm going to go in through my R600 unit. I'll just turn that on. And pop open the door. Let's plug that in. And now we're pulling power from here out to the 24, to the 12, and then out to the cigarette lighter adapter. And I'll just hold that up, and we'll turn that on. And we'll actually get a gauge now, tell us exactly how much power that's pulling. So you can see it's lighting up. And I'm pulling 167 watts right now. So that's roughly, a little higher even, that's roughly sitting up at about 13, 14 amps. So either way, this circuit is designed to handle 20 amps, so there's no worries in that regard. But you can see this solar generator is able to handle that level of output, and it's having to use a little bit of extra power because of the fact that it's converting it from AC to DC and down to a different DC, and then, you know, like, there's losses in that. But typically speaking, this would run close to about 150, 155 watts. Normally, if I just plugged it straight into a cigarette lighter with none of the extra circuitry in it. So even though it's costing me a bit of watts, I'm okay with that. Because as you could see in the example, I'll just stop and pan back up again. So you can see in the example here that I've only connected to the one MC4. I potentially could go out to this one as well if I had another buck converter here. And instead of just being able to run one pot, which I'm heating up, and as you can see, that light's still going, that pot's getting hotter and hotter. I really shouldn't let it run dry heat, so I don't want it to get too hot, but yeah, it's already getting hot enough to not even touch me. But you can see I'm not tripping it. It can handle the load easily. And now this unit here, I've shown in previous videos where I've gotten up close. I'm just going to unplug this because it's not going to trip, but I just wanted to show you longevity, yeah? So I'll unplug that. Hopefully that just cools down and I didn't, you know, get it too hot. But and you can see the power drops down. It's only using about 7-8 watts worth of power being consumed by this unit to do this transition. It's not using massive amounts of energy that way in the conversions. They're really quite efficient. This is about 90-95%, that's about 90-95% efficient. You know, it's really the AC coming off of the solar generator to begin with that's the least efficient, but that's a side issue. These losses are fairly minimal for the functionality that it gives you. And like I said, I could easily turn around and have a third one of these MC4 connections on, run out to these buck converters on each one, and put out 3 cigarette lighter adapters and be able to plug in different cooking utensils all off of this single small scale solar generator and be able to run them all at the same time. And as I've shown in the previous video, how I can use a larger battery to just supply power into this to kind of buffer the power loss. It allows me to cook large scale meals that would have, you know, multiple pots worth of food, and successfully be able to do that, you know, while only taxing this small little solar generator. But I'm going to shift camera angles now, and I'm going to shift gears and show you kind of some of the other added functionality I can get to using this kind of unit in my constructs, and why you'll see that for, you know, this was less than $100, and this was less than $100. Each one of these, I think this was about 50 bucks and 50 bucks, but, you know, that's Canada and it's time sensitive, so, you know, don't quote me on exact figures, but these are relatively cheap units for the functionality they give you in relationships to some of the other electronics you buy that can get more pricey, like large inverters and that kind of stuff, yeah? But one way or the other, like I say, I'll shift gears and I'll show you some of the different kind of functionality we can get now using this exact setup and just rewiring it slightly differently. Okay, so now I'm going to shift gears a little bit, like I say, and show you a totally different kind of construct you can do using the same kind of gear. So I switched the wiring of this 24 volt DC, and I just hooked it back onto the inverter that we had before. Now, as shown out in previous videos, typically I would have a central large battery bank stack that I would have, you know, larger inverters coming off of that then feed off to all these smaller systems that could be located in different areas around the environment you're wanting to set up. You know, if you're wanting to do a cabin or something like that, you might want to have these things be portable and just kind of have them spread out in different rooms and that kind of stuff. It's totally, you know, arbitrary how you'd set that up. But I want to show you now how this like emulates being a solar charger through these same MC4s. I just disconnected that 12 volt cigarette lighter stuff, and we'll kind of move away from that part now. And I'll show you that the connections for these solar generators can vary. In one situation, I've got like an Anderson style plug here that plugs into this S300 unit by All Powers, and then I've got an R600 by All Powers, and this one plugs into an XT60 connection, which really these are better connections and can handle higher levels of amps. But as you can see, the MC4s are kind of a standard theme when it comes to this kind of stuff. So when it comes to connecting these up now, what I'll do is just connect those as I normally would a solar panel, say. But instead of the solar, I'm hooking right into that 24 volt DC, and just plug all that in, make sure it's all firm. And I'm gonna plug this into the side now of the unit where the solar panels would normally plug in. And I'm just gonna plug this in instead and emulate like it's a solar panel. And it'll be the exact same thing on this one, where I'm just gonna turn around and take the unit. It's got, like I say, a little Anderson connection, and I've shown this all in details in previous videos. So if you haven't seen this and you want to see, you know, full details of this stuff, it's all in previous videos on my channel. It's readily available. But needless to say, I'm not really the biggest fan of those Andersons, but I'm going to turn around and plug this in exactly the same way. And now I've got these both hooked up. And when I turn on the power supply from that large battery that we had, let me pan you up a bit, using this kind of larger battery, and I could have a stack of those as my main core in my system, and have the, you know, larger inverters and a couple smaller inverters hooked into that were feeding off all my AC stuff for whatever use I wanted for larger scale stuff, yeah? But as soon as I turn this on now, it'll automatically light this up. And now this is already starting to take a charge, and so is this. So you can see now, even with dissimilar systems, this single unit is able to charge both with different inputs, as long as you got the wiring of, you know, to an Anderson or to whatever. And in essence, what it's doing now is this 24 volt isn't being converted down to the 12. It's being passed out to the solar panel input on these units, and it's faking like it's a solar panel. You know, solar panels normally sit anywhere from, say, you know, 16 volts for the crappier ones, all the way up to, you know, 22, 23. I'm just talking simple single solar panels in voltage. So when this is already right at the threshold of what a normal single good quality solar panel would be producing, you know, in ideal conditions. So these systems are designed to handle it. And as you can see, this is taking in 72 watts worth of power, and this is taking in 68 watts worth of power. So, you know, I'm able to run this all easily off the 600 watt inverter. It can handle it. If these batteries were a little lower, like this one was, you know, barely used, it was almost 100%. But if it was a little lower, it could pull up to 200 watts worth or so, and this one can pull 100 or so. But this inverter that I have here is a pure sine wave inverter. It can handle 600 watts. So even if there's losses going through here of 10, 15 watts, you know, it's not a big deal. It's not a showstopper, but it gives me the functionality now where I can easily chain together multiple systems. I could leave all of this pretty well like hardwired together to my main inverter and now have it that these never even have to touch a solar panel, but they're always being topped up. And with some good, you know, decent extension lines, you know, run them out 20 foot in any direction. So, you know, you have a central power bank that's supplying different rooms worth of power and all that kind of stuff, where they've got USB and lighting even on units like this, you know, to the degree where the main solar panel, as I've talked about in previous videos, if you had a large solar panel or you had a solar panel array, you could hook it up to these larger batteries. And like I say, it was only a video or two ago I detailed all that out. So if you're curious about, you know, how to do that part, I went through full detail in the previous video about how to wire up you know, solar panels up to the stack of batteries, and how to do it either in parallel or you can do it in series. You know, that stuff is relatively easy. You know, positive to positive, negative to negative is parallel, and positive to negative and then having opposing terminals is, you know, serial. It's elementary stuff. There's not much to it in that regard. But needless to say, you can see here, I now have the one solar system charging the two others. And it's amply able to do that. There's a 1280 watts of power that can sit into this larger battery here, this Li-Time, and this unit can only handle 300 watts worth of power or so, and this unit's about the same. So combined from dead to full, these are only going to take about half the power that's sitting in that large battery in total anyways. So there's a bit of buff and you know, buffer there for if the weather's seasonal and stuff, you get a bit of cloud and rain and stuff. And these units can normally, if you're only running, say, USB lights and maybe plugging in your cell phones and tablets and that kind of stuff, these units can run for 3 or 4 days just doing those tasks on a regular basis, consistent, always keeping your stuff fully charged without any issue, yeah? So I'll stop and shift camera angles again a bit and just show you that a little variance to this kind of theme, and you know how we can work it even from one unit to the next, yeah? So now I just unplugged it from the larger bank that I had, and I'm just going to plug it in to the R600. Now this has a pure sine wave inverter in it, and all I did was unplug the charging connection that it had to it from the larger inverter. I just unplugged that as well because I don't want it to feed power into itself and charge itself. That's just, you know, it gets crazy that way. I mean, it's doable, but it gets crazy. But I'll just turn this back on here and kick the inverter on. Now I can go even off of one of these smaller solar generators. It'll come out through here, kick this on, and now it's going to charge this unit, and it's already starting to. So, you know, you can do this at any point in the line, where having this kind of setup is as simple as literally just having one of these AC inputs free. I could have it connected this way, where this AC just connected and hardwired right up to that, and just had this unit sitting in, you know, in between, if you will, that I shut on and off whenever I wanted to. But you can see this unit's now charging this unit without issue, right? And the same goes, and it's kind of becomes nonsensical when you're wanting to go from the smaller units up to the larger ones, but the same goes that way. I've got this PWM charge controller, which typically I would use with the large setup with the larger inverter and all that kind of stuff, but it as well has the solar panel MC4 inputs. So I could easily just disconnect from right here where I was connecting into the R600. I'll just disconnect that entirely because its connection is an XT60, and now when I want to connect off to the battery, I can simply plug in these into here. It'll light up this PWM, and now I connect the positive and negative. I just don't have it wired up, so I'm not going to bother, but I could connect that up to the large battery and have it where any one of these units were powering up and charging the other. Like I say, typically speaking, you're always going to want to go from your larger battery stacks because they have the amperage stores in them. You're going to want to go from these kind of larger battery banks out to the smaller units. But if for some weird reason you have barely any power in your large stack, you can siphon the energy back off your smaller ones with some losses, put it back in that big stack. Say you were desperate to get a larger inverter up and running to, you know, have enough watts to cook a meal or something. That was your primary target. And you didn't, you know, you didn't have enough energy in the primary stack, but you would with everything combined. In those types of scenarios, you can pull off getting away with this kind of stuff. You know, for safety's sake, generally speaking, my only rule of hesitation with doing any of this kind of stuff is I don't want to go from being a modified sine wave inverter, which I'm not sure if this is a pure sine wave AC output or not on this S300. I just can't remember. I'd have to go back and look again. But if this is not a pure sine wave, I'm not going to want to go off the AC here out to there and then back out the other way, because I just don't trust modified sine waves inverters in any way. Typically speaking, they're cheaper and put out a dirtier form of energy, whereas I know this RS600 has a pure sine wave inverter, so I don't mind sending the power out that way. But as you can see, there's 78 watts of power output coming off this unit, and on this side you got 61 watts going into this, so that's accounting for all the losses and everything else. You know, yes, you are losing some power, there's no argument in that regard, but it gives me the ability to throw power around in my different devices and use them together in combination. Like I said earlier in the video, it would have been absolutely impossible for this R600 to run 3 cigarette lighter adapters if I wanted to go up to 3 of them. To run those and be able to cook full meals in that, this gear can handle that wattage output from the battery. It's just the circuitry here, the way it's been built, has a threshold, and it stops and protects itself with that threshold. I just simply have a higher threshold. But by switching it up to the AC, it allows me to get around that problem and go fully out to where I can run 3 of them at a time instead of can't even run 1. And I didn't change my unit, I just used the 2 in combination with each other, yeah? So hopefully that gives you an idea now. I'll just turn this off because I know this fan gets a little loud. But hopefully that gives you an idea of some of the versatility of what you can do with these small scale systems and kind of how you can get them to interwork with each other. So I'll just shift camera angles and I'll kind of start to wrap this up though, yeah? So like I say, adding in something as simple as this 24 volt DC switch power supply. You know, like I say, they're fairly common units that exist now. You can get them for well less than $100 for ones that are, you know, half decently powerful. If you want super powerful ones, it's over $100. But generally speaking, they're cheap and reliable units, you know, and they're efficient and everything else. And the good part about having this kind of flexible setup is I can have everything you've just seen there. You know, you can conveyance that into, say, a base camp. But you can see, if I don't want to use my 12 volt stuff, I can break it off entirely and just be in a 24 volt system where it's charging things and everything else. But I can now take this into the field and have it where I just plug directly into solar panels on this MC4 connection as a standard solar panel. And as long as I've got about a 200 watt and 170 watt bottom level, but a 200 watt solar panel, 250 is even better, I can turn around and come out to these cigarette lighter adapters all in one single unit, which allows me to run my cooking pots and everything else on the fly with minimal amounts of gear. You know, this, a solar panel, and the pot is all I really need in those regards, right? But hopefully this gives you an idea of, you know, how you can join together some of these simpler units and, you know, get it to do higher level production. In previous videos, I showed where I used the R600 to run an induction stove element, and I ran it between 300 and 700 watts because that's the settings on the induction motor, but I was successfully able to cook a full stir fry off of this. I can have it where the main unit is throwing a charge into this and it's off running, you know, at 500 watts, say, it's off running at the same time and running 2 induction cooktops at the same time. So I can scale all the amount of cooking and everything I can do. I can scale it up fairly substantially without having to really get a lot more additional equipment. you know, and I'm showing a lot of the AC and, you know, kind of working with cooking in that regard, because I've done a lot of previous videos. I've done a lot of details about 12 volt cooking. And generally speaking, I find that to be kind of more ideal, more efficient in the regards of you're using less voltage and lower levels of, power all around. You've got an increase of amps to give you heat, but generally speaking, I've already covered the 12 volt cooking, and I have a lot of that equipment. And one of the key things I really wanted to do was marry that equipment up to these small scale systems. And you think, like, if a single 12 volt cooking pot is using 150 watts, well, 300 for 2, 600 for 4 pots. You know, I could potentially cook 4 pots of food at the same time off this unit. And then the only thing I have to worry about is the limitations of the battery, and this unit can only hold about 300 watts. So I have to wire up this larger unit to be charging this unit to give it that continual power. And that's part of how you start to use all these things in combination with each other, depending on how you set them up and configure them, yeah? But hopefully that was an eye-opener for people that are, you know, into solar stuff, and you're kind of wondering, you bought yourself a bunch of small systems, because they are expensive, and I get it. You didn't want to scale up to this big massive system, but you do want to kind of get higher levels of productivity out of your systems, and you want to have them be able to interwork with each other, if you will. And this kind of setup I like. It's modular, it's flexible. I can pack in different components as I move through time. If I'm in a remote location, you know, all these units, I could put everything here into a single bag that would probably weigh about 50 pounds. So you could move all of this in one go and have it be, you know, doable to move into backpacks, eh? Now I'm giving an example. But the thing I like about it is because there's the flexibility where I can pop a piece out and use it for doing something else, and I can swap things around. If you're out in the field, when you have a part break, you don't want to have it be critical to a centralized system where if that one component breaks, everything's useless because that's no longer working. When you have modular systems like this, it's really wires and stuff that you'll carry maybe a couple multiples of. But the systems are, generally speaking, if I lost one of my solar generators, it just went down and wasn't working, at least I'd have the other two in operation that I could do things with. You know, that it's not critical if you lose a component, and you can toggle your components around to be able to achieve a lot of different flexible things. So I'll kind of wrap it up. Normally I do longer videos, but like I say, it was just monsoon season outside, and I've really been trapped indoors over the entire weekend. It's just terrible out there. But one way or the other, hopefully you guys enjoyed this content. And if you do, you know, please like, share, and subscribe, and all that kind of happiness. And thanks for watching, yeah? Cheers.